There is a moment, if you allow yourself to sit with it long enough, when the night sky stops feeling like a ceiling and starts feeling like a wound. Not a wound in the poetic sense, not a romantic tear in the fabric of something beautiful, but a genuine rupture in your understanding of where you are and what surrounds you. The stars do not fill the darkness, they punctuate it, and the darkness between them is not a background, it is the dominant condition of everything that exists. You have been told in one way or another that the universe is vast. That word vast has been used so many times in so many contexts that it has lost almost all of its weight. We say vast the way we say far, or deep, or ancient, as though the word itself can carry the scale it is trying to describe. It cannot. No word can. But there is something more unsettling than the size of the universe, something that the word vast quietly conceals. The universe is not merely large. It is in almost every measurable sense profoundly, structurally, and irreversibly empty. The window is open for now. And while the universe is still readable, subscribe to Beyond the Universe and stay with us as we step deeper into the silence. This is the kind of emptiness that does not simply mean there is nothing nearby. It means that the overwhelming majority of all space that exists, across every direction, at every scale above a certain threshold, contains almost nothing at all. Not thin clouds of gas, not scattered dust, not the faint residue of ancient events. Almost nothing. The emptiness of the universe is not a side effect of its size. It is one of its most fundamental properties, and understanding it changes the way every other fact about the cosmos feels. What you are about to encounter here, on Beyond the Universe, is not a tour of the cosmos in the familiar sense. It is something closer to an investigation into what the universe is actually made of, how it is actually arranged, where it is actually going, and what that destination means for everything that has ever existed inside it. Stay with this, because the further in you go, the less comfortable the answers become. Start with what you know, or rather, start with what you think you know. Stand outside on a clear night, far from city lights, and look upward. The sky appears populated, densely, almost generously populated, thousands of individual stars visible to the naked eye, and behind them, if you know where to look, the faint smear of the Milky Way itself, a river of unresolved light that represents hundreds of billions of stars too distant to distinguish individually. It looks full. It looks like the universe is a place where things exist in abundance, where light is common, where matter is everywhere. But that impression is a product of proximity. You are standing on a planet orbiting a star, and that star is close, cosmically, absurdly, almost embarrassingly close. The light from the sun reaches you in about 8 minutes. The next nearest star system is over 4 light years away, which means its light takes more than 4 years to arrive. And already, in that single comparison, the scale begins to shift. The stars you see at night are not a representative sample of the universe. They are your immediate neighborhood, and your immediate neighborhood is extraordinarily unusual in its density of visible objects. Move outward, not in imagination, but in measurement. When astronomers began mapping the distribution of galaxies across larger and larger volumes of space, they expected to find something roughly uniform. The assumption, reasonable on its surface, was that matter would be spread throughout the cosmos in a more or less even distribution, perhaps with some clustering here and there, but fundamentally consistent. What they found instead was something that no one had fully anticipated, something that took decades to map with enough precision to understand, and something that, once understood, made the universe feel like a fundamentally different kind of place. Matter is not evenly distributed, not even close. On the largest scales we can observe, the galaxies of the universe are arranged into an intricate web-like structure. Long filaments of galaxies stretch across hundreds of millions of light years, connecting at dense nodes where galaxy clusters pile up in gravitational knots of extraordinary mass. Flat sheets of galaxies, sometimes called walls, extend across the sky like the surfaces of enormous geometric forms. And between all of these structures, between the filaments and the walls and the clusters, there are voids, regions of space so large, so thoroughly emptied of galaxies, that the word void barely does them justice. Imagine a structure so large that if you placed our entire local group of galaxies, the Milky Way, Andromeda, and all their smaller companions, inside one of these voids, it would be like dropping a single grain of sand into an empty stadium. The void would not notice. The local group would be invisible against the scale of the absence surrounding it. These voids are not gaps in the data. They are not regions we have not yet mapped. They are real, confirmed, measured absences, and they are among the largest coherent structures in the observable universe. The Bode's void is one of the most studied examples. Roughly spherical, approximately 330 million light-years across, it contains almost no galaxies in its interior. A handful of galaxies have been found within it, but they are so sparse, so isolated from one another, that their presence only deepens the sense of the void's emptiness, rather than relieving it. If you were somehow positioned at the center of the Bode's void and looked outward in every direction, you would see almost nothing. No galaxies, no clusters, no filaments, just the faint ancient light of the cosmic microwave background, the residual glow of the early universe, and the darkness between you and the distant walls of the void, where galaxies finally begin to appear again. And the Bode's void is not even the largest. There are supervoids, regions even more expansive, even more thoroughly emptied, that span distances so great that light traveling at its maximum speed would take hundreds of millions of years just to cross them. These are not anomalies. They are features. They are part of the architecture of the universe, as fundamental to its structure as the filaments and walls that surround them. This is the first thing that needs to settle into your understanding before anything else can follow. The universe is not a place where matter exists with occasional gaps. It is a place where absence is the dominant condition, and matter exists in thin, intricate web-like concentrations that trace the boundaries of vast, dark, nearly empty cavities. The cosmic web is not a description of where things are. It is a description of where almost everything is not, but it goes deeper, because the question that immediately follows the discovery of this structure is not simply where the galaxies are. It is why they are arranged this way. Why do galaxies cluster into filaments and walls? Why do voids exist at all? Why is the distribution of matter in the universe so dramatically uneven, so structured around absence rather than presence? The answer to that question leads somewhere unexpected, somewhere that makes the emptiness of the universe feel not just large, but architecturally deliberate, shaped by forces and substances that we cannot see, cannot touch, and cannot fully explain. But before that answer, consider what the structure itself implies about your position in the cosmos. The Milky Way is not at the center of anything. It is not in a particularly dense region of the cosmic web. It is not at a node where great filaments converge. It sits in a relatively modest cluster of galaxies, the local group, which is itself part of a larger supercluster called Laniakea, a gravitational basin containing hundreds of thousands of galaxies spread across roughly 500 million light-years. Laniakea is large by human standards. By cosmic standards, it is one feature among many, one concentration among countless others, embedded in a web that extends in every direction to the limits of what we can observe. There is no center. There is no edge that we can point to and say, here is where the universe ends and something else begins. There is only the web and the voids and the expansion that carries all of it outward in every direction simultaneously. The Milky Way is not special. It is not privileged. It is not positioned at a meaningful location in any cosmic sense. It is simply here in one of the countless ordinary positions that the web contains, surrounded by the same darkness that surrounds every other galaxy in every other position. That realization, taken seriously, is not comfortable. We have spent most of human history assuming in one way or another that we occupy a meaningful position, that the place where we exist has some relationship to the center of things, to the origin of things, to the purpose of things. Cosmology has spent the last several centuries systematically dismantling that assumption, and the large-scale structure of the universe is one of its most thorough dismantlings. We are not at the center. We are not near the center. The concept of a center, in the cosmological sense, does not apply to the universe we actually inhabit. Return now to the voids, because there is something about them that goes beyond their size, beyond their emptiness, beyond their role in the cosmic web. There is something about the experience of imagining yourself inside one that changes the texture of the emptiness in a way that mere numbers cannot achieve. Place yourself in thought at the geometric center of a large cosmic void, not at the edge, where the faint light of distant filaments might be visible on the horizon of your perception, but at the true center, as far from any significant concentration of matter as it is possible to be within that structure. In every direction, for hundreds of millions of light-years, there are almost no galaxies. The nearest significant concentrations of matter are so far away that the light you would see from them left before complex life existed on Earth. The universe around you is not dark in the way a room is dark when the lights are off. It is dark in the way that distance is dark, in the way that separation is dark, in the way that the absence of any nearby source of light or warmth or structure creates a silence that is not merely auditory but spatial, dimensional, total. You would not be in danger in any conventional sense. There would be no threat, no predator, no catastrophe bearing down on you. The void is not hostile. It is simply indifferent, and its indifference is expressed through an emptiness so complete that the word indifference itself feels too small. The void does not ignore you. It simply has no mechanism by which your presence could register as anything other than an infinitesimal fluctuation in an otherwise featureless expanse. This is what the universe is mostly made of. Not stars, not galaxies, not the spectacular nebulae and colliding clusters that fill the images we use to represent the cosmos. Those things exist, and they are real, and they are extraordinary, but they are the exception. They are the thin, bright, intricate exception to a rule that is written in darkness and distance and the near total absence of anything at all. The cosmic web, for all its visual complexity when rendered in simulations and maps, is itself a structure defined more by what it excludes than by what it contains. The filaments are thin, the walls are thin, the nodes are dense but small relative to the volumes they anchor. If you were to take the entire observable universe, everything within roughly 46 billion light-years of Earth in every direction, and compress it into a sphere the size of a basketball, the filaments of the cosmic web would be thinner than the finest thread you could see with the naked eye. The voids would be the basketball itself. The matter would be the thread. And even that thread, even the filaments and walls and clusters where matter actually concentrates, is not made primarily of the kind of matter you are familiar with. The atoms that form stars, planets, oceans, atmospheres, and living bodies, the ordinary matter that constitutes everything you have ever seen or touched or measured directly, represents only a small fraction of the total mass and energy content of the universe. The rest is something else, something that does not emit light, does not absorb light, does not interact with ordinary matter in any of the ways that ordinary matter interacts with itself, something that is present everywhere, shaping everything, and yet completely invisible to every instrument we have ever built to detect it. The universe you can see is not the universe that exists. The visible cosmos, the stars and galaxies and glowing clouds of gas that fill our telescopes and our imaginations, is a thin layer of luminous material draped over a much larger, much more massive, and entirely invisible structure. And understanding that structure, understanding what it is and what it does and why it exists, is one of the deepest and most unsettling challenges in all of science. But it gets worse, because the invisible structure is not the only thing shaping the universe. There is something else, something even less understood, something that does not merely shape the distribution of matter, but actively governs the behavior of space itself. Something that is not matter at all, not in any sense we currently understand, but that constitutes the largest single component of the universe's total energy budget. Something that is right now, at this moment, causing the universe to expand faster than it was expanding yesterday, and slower than it will be expanding tomorrow. The universe is not simply large and empty and structured around absence. It is also accelerating away from itself. Every region of space is moving away from every other region, not because of any explosion or initial impulse that is gradually slowing down, but because something is actively pushing the expansion faster. The distances between distant galaxies are not merely growing, they are growing at an increasing rate, and the implications of that acceleration, followed to their logical conclusion, lead to a future so isolated, so dark, so thoroughly stripped of the conditions that make observation and knowledge and complexity possible, that the word emptiness begins to feel like an understatement. But that is where this investigation is going, not toward comfort, not toward resolution, toward the full weight of what the universe actually is, what it is actually doing, and what it is actually becoming. The emptiness you see when you look at the night sky is not the beginning of the story. It is barely the surface of it. Beneath the surface, the universe is stranger, darker, and more thoroughly committed to its own dissolution than anything the visible sky suggests. Consider again the structure of the cosmic web, but now consider it not as a static map, but as a record of process. The filaments and walls and voids did not appear fully formed. They grew. They emerged from conditions that existed in the very early universe, when matter was distributed almost uniformly, with only the faintest, most delicate variations in density from one region to another. Those variations, tiny as they were enough. Gravity, patient and relentless, began pulling matter toward the slightly denser regions. Over hundreds of millions of years, those regions grew denser still, while the regions that were slightly less dense grew emptier. The process compounded itself. Density attracted more density. Emptiness deepened into void. The result, after billions of years of gravitational sculpting, is the cosmic web we observe today. A structure that looks in large-scale maps almost biological, almost like the neural network of some unimaginably vast organism, with bright nodes connected by luminous threads and surrounded by dark, hollow spaces. The resemblance is striking enough that it has been noted many times, but the resemblance is coincidental. The cosmic web was not designed. It was not intended. It emerged from the mathematics of gravity, operating on the initial conditions of the universe, and it would have emerged in roughly the same form, regardless of whether anything was ever alive inside it to observe it. That is perhaps the most quietly disturbing aspect of the cosmic web's existence. It is not a backdrop for life. It is not a stage on which the drama of existence plays out. It is a physical consequence of initial conditions and physical laws, and the fact that it contains, somewhere in one of its filaments, a small galaxy with a small star and a small planet where something capable of mapping the web came into existence is not a feature of the web. It is an accident of the web, a local fluctuation, a temporary exception to the overwhelming rule of emptiness and silence that defines the structure as a whole. The voids are not empty because something removed the matter from them. The matter was never there in significant quantities to begin with. The voids are the regions where the initial density was slightly lower than average, and where gravity's long work of concentration pulled what little matter existed toward the surrounding filaments, leaving behind a space that was already sparse and became, over cosmic time, nearly barren. The voids are not scars. They are not absences left by some catastrophic removal. They are simply the places where the universe never bothered to concentrate itself, the regions where the cosmic web decided, through the blind arithmetic of physics, not to build anything, and they are growing. As the universe expands, the voids expand with it. The walls of the voids, the filaments and sheets where galaxies cluster, are being carried outward by the expansion of space, and the interiors of the voids are becoming proportionally larger, proportionally emptier, proportionally more isolated from the structures that surround them. The cosmic web is not a fixed architecture. It is a dynamic one, and the direction of its dynamism is toward greater separation, greater emptiness, greater distance between the concentrations of matter that give the universe its visible structure. There is a question that sits underneath all of this, one that the structure of the cosmic web raises but does not answer. If gravity pulls matter together, if the process of cosmic web formation is fundamentally a story of concentration and clustering, then why is the universe still so overwhelmingly empty? Why, after billions of years of gravitational work, does matter occupy such a tiny fraction of the total volume of space? The answer is that gravity, for all its patience and persistence, is working against something that operates not on matter, but on space itself. Something that is not pulling things together but pushing everything apart, and that something is winning. The something that is winning does not have a satisfying name. Dark energy is what we call it, but the name is less a description than a placeholder, a label attached to a phenomenon we can measure in its effects but cannot explain in its nature. Before arriving at dark energy, though, there is another layer of the invisible that needs to be understood, because it sits between the visible matter you can see and the accelerating expansion you cannot stop. It is the hidden scaffolding upon which the entire visible universe is constructed. It is the reason the cosmic web has the shape it has. It is the reason galaxies exist at all in the form they take. And it is, by every measurement we have, far more abundant than everything you have ever seen combined. Dark matter. The phrase has become familiar enough that it no longer sounds strange, and that familiarity is a problem, because familiarity breeds the illusion of understanding. Most people who have heard the term have absorbed a rough approximation of what it means. There is matter we cannot see. It has gravity. It affects galaxies. That approximation is not wrong, but it is so incomplete that it misses the thing about dark matter that should genuinely unsettle you. Dark matter is not simply invisible matter. It is matter, or something that behaves like matter, that exists in a completely different relationship to the physical world than anything you have ever encountered or could ever encounter directly. Ordinary matter, the matter that forms you and the chair beneath you and the planet beneath that and the star at the center of this solar system, interacts with the universe in multiple ways simultaneously. It has gravity. It also interacts electromagnetically, which means it can emit light, absorb light, reflect light, and be affected by electric and magnetic fields. It can collide with other ordinary matter and transfer energy. It can form chemical bonds. It can build structures of extraordinary complexity, from crystals to proteins to planetary crusts to stellar cores. Ordinary matter is, in a sense, socially promiscuous. It participates in the full range of physical interactions available to it. Dark matter participates in almost none of that. It has gravity, or something that produces the same effect as gravity, and that appears to be essentially the extent of its engagement with the rest of the universe. It does not emit light. It does not absorb light. It does not interact electromagnetically in any way we have been able to detect. It passes through ordinary matter as though ordinary matter is not there. If a cloud of dark matter were moving through the room where you are sitting right now, you would not feel it. Your instruments would not detect it. The atoms of your body would not register its passage. It would move through you and through the walls and through the planet beneath you and out the other side, and nothing in the physical world you inhabit would record the event. And yet it is there. We know it is there not because we have detected it directly, but because its gravitational influence is written into everything we can observe. The rotation of galaxies is the most famous evidence. Stars in the outer regions of spiral galaxies orbit the galactic center at speeds that should not be possible if the only mass present were the visible stars and gas. By the mathematics of gravity, stars at the outer edges of a galaxy should orbit more slowly than stars closer to the center, just as the outer planets of our solar system orbit the sun more slowly than the inner ones, but they do not. The outer stars of most spiral galaxies orbit at roughly the same speed as the inner stars, or even faster. The rotation curves of galaxies are flat when they should decline. The only explanation that fits the data is that there is additional mass present, mass that is not visible, mass that extends far beyond the visible disk of the galaxy in a large, roughly spherical halo. This halo of dark matter surrounds the visible galaxy the way an atmosphere surrounds a planet, except that the dark matter halo is far larger than the visible galaxy it envelops, and far more massive. The stars and gas and dust that you can see when you look at a galaxy are not the galaxy in any complete sense. They are the luminous core of a much larger, much more massive and entirely invisible structure. The galaxy you see is the bright center of something you cannot see. This is true of the Milky Way. The visible disk of our galaxy, the flat spiral structure containing hundreds of billions of stars, is embedded in a dark matter halo that extends for hundreds of thousands of light years in every direction. The halo is not a shell. It is a diffuse, roughly spherical distribution of dark matter that dwarfs the visible galaxy in both size and mass. When astronomers calculate the total mass of the Milky Way, the dark matter halo accounts for the majority of it. The stars, the gas, the dust, the planets, everything that emits or reflects light, everything that has ever been directly observed, is a minority component of the galaxy's total mass, and this is not unique to the Milky Way. Every large galaxy we have studied shows the same pattern. Every galaxy cluster we have examined contains far more mass than its visible galaxies can account for. The gravitational lensing of light around galaxy clusters, the way massive objects bend the path of light passing near them, reveals mass distributions that are far larger and far more extended than the visible matter alone could produce. The invisible outweighs the visible everywhere we look, by a ratio that is not close. For every unit of mass in ordinary matter, there are roughly 5 units of dark matter. The universe is, by mass, approximately 5 times more dark than it is visible. But it goes deeper, because dark matter is not merely a correction to the mass budget of individual galaxies. It is the reason the cosmic web exists in the form it does. In the early universe, when matter was distributed almost uniformly, the slight variations in density that would eventually grow into the filaments and voids of the cosmic web were present in both ordinary matter and dark matter. But dark matter, because it does not interact electromagnetically, was not subject to the radiation pressure that kept ordinary matter from clumping in the early universe. While ordinary matter was being pushed around by the intense radiation of the early cosmos, dark matter was free to begin gravitationally clustering on its own. Dark matter formed the first structures. It collapsed into halos under its own gravity while ordinary matter was still being held in a hot, dense, radiation-dominated plasma. By the time the universe cooled enough for ordinary matter to decouple from radiation, by the time atoms could form and matter could begin to move freely under gravity, the dark matter halos were already there, waiting. Ordinary matter fell into the gravitational wells that dark matter had already excavated. The visible universe, the stars and galaxies and filaments that we observe, formed inside a pre-existing invisible architecture that dark matter had already constructed. The cosmic web is not a structure of galaxies. It is a structure of dark matter, and the galaxies are the luminous tracers of that structure, the visible foam on the surface of an invisible ocean. The filaments you see in large-scale maps of the universe are dark matter filaments, with galaxies clustered along them because ordinary matter followed the gravitational paths that dark matter laid down. The voids are not simply regions where galaxies are absent. They are regions where dark matter is also sparse, where the invisible scaffolding itself is thin, and where ordinary matter had no gravitational invitation to gather. This reframes the emptiness of the universe in a way that makes it simultaneously more structured and more disturbing. The voids are not random, they are not accidents. They are the negative space of a dark matter architecture that spans the entire observable universe. The emptiness is not featureless, it is shaped. It is the interior of a mold, and the mold is made of something we cannot see, cannot touch, and cannot explain at the level of fundamental physics. We know the mold exists because we can see what it has shaped. We cannot see the mold itself. Imagine trying to understand the structure of a sculpture by looking only at the empty space around it. You could infer the shape of the sculpture from the shape of the space it displaces. You could map the boundaries of the absence and reconstruct, in negative, the form of the thing you cannot see. That is, in a rough sense, what cosmologists do with dark matter. They map the gravitational effects, the distorted light, the anomalous velocities, the unexpected mass distributions, and from those effects, they reconstruct the invisible structure that must be present to produce them. The sculpture exists. They can prove it exists. They simply cannot look at it directly. And the sculpture is enormous. The dark matter structure of the universe is not a collection of individual halos around individual galaxies. It is a continuous, interconnected web that spans the entire observable cosmos. The halos around individual galaxies are connected to the halos of neighboring galaxies through dark matter filaments. Those filaments connect to the larger dark matter structures of galaxy groups and clusters. The clusters connect to superclusters. The superclusters are embedded in the largest dark matter structures of all, the great walls and sheets that define the boundaries of the cosmic voids. The entire visible universe is threaded through with an invisible web that is older, larger, and more massive than everything you can see. There is something philosophically vertiginous about this. The universe you observe, the one that fills telescopes and inspires wonder and provides the data from which all of cosmology is constructed, is not the primary structure of reality. It is the secondary structure. It is the visible consequence of an invisible cause. The real architecture of the cosmos is hidden, and what we call the universe, the luminous, observable, measurable universe, is a kind of shadow cast by something we have never directly seen. But it gets worse, because dark matter, as strange and invisible and inexplicable as it is not the dominant component of the universe. It is not even close to the dominant component. Dark matter constitutes roughly 27% of the total mass energy content of the universe. Ordinary matter, everything made of atoms, everything that has ever been directly observed or touched or measured, constitutes roughly 5%. Together, ordinary matter and dark matter account for approximately 32% of the universe's total energy budget. The remaining 68% is something else entirely, something that is not matter at all, not in any sense we currently understand. Something that does not cluster, does not form structures, does not follow the gravitational logic that governs both ordinary and dark matter. Something that is distributed uniformly throughout all of space, in every direction, at every location, and that is actively, measurably, and increasingly causing the universe to expand faster than it otherwise would. This is dark energy. And if dark matter is the invisible architecture of the universe, dark energy is the invisible behavior of space itself. It is not a substance in the way that matter is a substance. It is not a field in the way that electromagnetic fields are fields, at least not in any way that current physics can fully describe. It is a property of space, or a component of space, or a consequence of the quantum nature of empty space, or something else entirely that we do not yet have the conceptual framework to properly name. What we know about it is almost entirely defined by what it does, and what it does is this. It causes the expansion of the universe to accelerate. To understand why that is disturbing, you need to understand what the expansion of the universe actually is. It is not galaxies moving through space the way a ball moves through air. It is space itself expanding, the fabric of space-time stretching, so that the distance between any 2 points that are not gravitationally bound to each other increases over time. Galaxies that are gravitationally bound, like the Milky Way and Andromeda, which are actually approaching each other and will eventually merge, are not being separated by the expansion. But galaxies that are far enough apart, far enough that their mutual gravitational attraction is weaker than the expansive tendency of space, are being carried apart by the expansion of the fabric between them. This distinction matters enormously. If galaxies were simply moving through space, then in principle, given enough time and enough technology, you could travel between any two galaxies by moving fast enough. The distance would be large, but it would be a fixed distance, a gap to be crossed. But if space itself is expanding, then the distance between two distant points is not fixed. It is growing, and if the expansion is accelerating, then the distance is growing faster and faster. And if the acceleration continues indefinitely, then there will come a point where the distance between two regions of space is growing faster than light can travel across it. At that point, those two regions become permanently, irreversibly disconnected, not because of any barrier, not because of any force preventing travel, but because the geometry of space-time itself is expanding faster than any signal, any light, any information can move. This is the concept of the cosmic horizon, and it is one of the most genuinely unsettling ideas in all of cosmology. There is already a horizon around us, a boundary defined by the distance that light has had time to travel since the beginning of the universe. Everything within that boundary is, in principle, observable. Everything beyond it is not, because the light from those regions has not had time to reach us. But the cosmic horizon created by accelerating expansion is different in kind. It is not a boundary defined by the age of the universe. It is a boundary defined by the rate of expansion, and it is a boundary that is, in a meaningful sense, closing in. As the expansion accelerates, the distance at which galaxies are receding from us faster than light increases. Galaxies that are currently beyond that distance are already beyond our ability to receive new information from. The light they emit now will never reach us, because the space between us and them is expanding faster than the light can cross it. And as the acceleration continues, galaxies that are currently within our observable reach will eventually cross that threshold. They will not move. We will not move. But the space between us will expand until the rate of that expansion exceeds the speed of light. And at that point, those galaxies will effectively vanish from our universe. Not physically, not literally, but informationally, causally, permanently. The galaxies that are currently visible in our telescopes, the hundreds of billions of galaxies that populate the observable universe, are not all going to remain visible. The ones that are far enough away are already receding beyond the point of no return. Their light is still reaching us because that light was emitted long ago, when the distances were smaller. But the light they are emitting now, the photons leaving those galaxies at this moment, will never arrive. We are seeing those galaxies as they were, not as they are. And we will never see them as they are, because the universe is expanding too fast for the present to reach us from those distances. This is not a technological limitation. It is not a problem that a more powerful telescope or a faster spacecraft could solve. It is a consequence of the geometry of an accelerating universe, and it is irreversible. The galaxies are not hiding. They are not blocked. They are simply being carried beyond the reach of any possible contact by the expansion of the space between us and them. And the process is ongoing. Every moment, the boundary of what is permanently reachable shrinks slightly. Every moment, a few more photons that were heading toward us from distant galaxies are redirected by the expansion of the space they are traveling through and will never arrive. Now consider what this means not for us in the present, but for any intelligence that might exist in the far future. We live at a particular moment in cosmic history, a moment that is, in several important ways, unusually rich in observable information. The universe is approximately 13.8 billion years old. It is old enough that the cosmic web has had time to develop its full structure, that galaxies have had time to form and evolve, that stars have had time to live and die and seed the cosmos with the heavy elements needed for planets and chemistry and life. But it is also young enough that the expansion has not yet carried most of the observable universe beyond the cosmic horizon. We can still see the large-scale structure. We can still detect the cosmic microwave background, the ancient light from the early universe that carries information about the initial conditions of the cosmos. We can still, in principle, reconstruct the history of the universe from the evidence available to us. Future observers will not have this luxury. In the far future, billions or trillions of years from now, the accelerating expansion will have carried most of the currently observable galaxies beyond the cosmic horizon. The night sky of a future civilization, if one exists, will be dramatically emptier than ours. The galaxies that currently populate our telescopes will be gone, not destroyed, but simply unreachable, their light perpetually outrun by the expansion of the space it is trying to cross. The cosmic microwave background, already faint and redshifted, will be redshifted further, stretched to wavelengths so long that detecting it will require instruments of unimaginable sensitivity, and eventually, it will be effectively undetectable. A civilization arising in the far future, in a universe that has expanded and cooled and isolated itself into a collection of gravitationally bound islands separated by unimaginable distances of empty, expanding space, would look at the sky and see almost nothing. They would see their own galaxy or their own local group of galaxies, because those are gravitationally bound and will not be separated by the expansion. But beyond that, they would see darkness. Not the darkness of a night sky with stars too faint to see, the darkness of a universe that has hidden its own history, that has expanded its evidence beyond the reach of any observation, that has made its own origin inaccessible. That future civilization, if it were scientifically sophisticated, might develop theories about the universe. It might measure the properties of its local galaxy and construct models of how it formed, but it would have no way of knowing that the universe contains hundreds of billions of other galaxies, because those galaxies would be beyond the horizon. It would have no way of detecting the cosmic microwave background, because that signal would be too faint and too redshifted to measure. It would have no way of knowing that the universe began in a hot, dense state and expanded over billions of years, because the evidence for that history would be gone. It might conclude reasonably and incorrectly that the universe consists of its local island and nothing more. We are not in that position. We can see the evidence. We can detect the cosmic microwave background. We can map the large-scale structure. We can measure the expansion and the acceleration and the dark matter and the dark energy. We live in a window of cosmic time when the universe is still readable, when its history is still written in the sky in a language we are only beginning to learn. But that window is not permanent. It is not even particularly long on cosmic timescales. It is a brief interval of observational richness in a much longer story that trends toward darkness and isolation and the erasure of accessible information. The universe is not simply expanding, it is becoming less knowable. It is moving, through the mechanism of accelerating expansion, toward a state in which the evidence of its own origin and structure is permanently hidden. The information is not being destroyed. The galaxies beyond the horizon still exist. The photons they emit still travel, but they travel into a space that is expanding faster than they can cross, and they never arrive. And the information they carry is lost to any observer on this side of the horizon as completely as if it had never been emitted. This is a form of cosmic forgetting, not the forgetting of a mind that loses its memories, but the forgetting of a universe that expands its evidence beyond the reach of any possible retrieval. The universe is not only getting larger, it is getting quieter. It is getting darker. It is getting more isolated. And the process is not slowing down. It is accelerating. Every moment, the universe is a slightly less connected, slightly less observable, slightly more isolated place than it was the moment before. And this leads to something more disturbing, because the isolation created by accelerating expansion is not the only process moving the universe toward darkness and silence. There is another process, slower in some ways but equally inexorable, that is working in parallel. A process that does not operate on the scale of the cosmos, but on the scale of every star, every galaxy, every concentration of matter in the universe. A process that is not about distance but about time, not about separation but about exhaustion. The universe is not only expanding away from itself, it is also running down. The stars are burning. That sentence sounds almost too simple to carry the weight it needs to carry, but consider what it means. Every star in the universe is a nuclear furnace, converting mass into energy through the fusion of lighter elements into heavier ones. The sun converts approximately 4 million tons of mass into energy every second. It has been doing this for approximately 4.6 billion years. It will continue doing it for approximately another 5 billion years before its fuel is exhausted, and it begins its transition into a white dwarf. Every star in every galaxy in the observable universe is doing something similar, on timescales that vary with the star's mass but that are, in every case, finite. The stars are not permanent. They are processes. They are the temporary conversion of gravitational potential energy and nuclear fuel into light and heat, and the heavy elements that seed the cosmos with the raw materials for planets and chemistry. They are extraordinary, and they are everywhere, and they are burning through their fuel at rates that, on cosmic timescales, are not sustainable. The universe has a finite supply of hydrogen, the primary fuel for stellar fusion, and that supply is being consumed, not quickly, by human standards, but steadily, irreversibly, and without any mechanism for replenishment. New stars form when clouds of gas collapse under gravity. That process is ongoing, and it will continue for a very long time, but it is already slowing. The rate of star formation in the universe peaked roughly 10 billion years ago and has been declining ever since. The universe formed stars most vigorously in its youth, when gas was abundant and the conditions for collapse were widespread. As that gas is consumed, as it is locked up in stars and stellar remnants and dispersed by stellar winds and supernovae, the raw material for new star formation becomes scarcer. The universe is not only burning its existing stars, it is gradually losing the ability to make new ones. This decline in star formation is not a crisis in any immediate sense. There are still vast quantities of gas in the universe, and stars will continue forming for billions of years to come. But the trajectory is clear, and the endpoint is not ambiguous. At some point in the far future, the gas available for star formation will be exhausted, the last stars will form, and after that, no new stars will ignite. The galaxies will age without replacement, their stellar populations gradually dying out, their light slowly fading as the most massive and luminous stars burn out first, followed by progressively smaller and dimmer stars over progressively longer timescales. The aging of the universe is not a metaphor. It is a physical process with measurable stages, and those stages follow a sequence that is, once you understand it, almost impossible to find comforting. The most massive stars, the ones that burn brightest and hottest and most spectacularly, exhaust their fuel in millions of years. They are the brief, violent exceptions in a stellar population dominated by smaller, dimmer, far more patient stars. When the massive stars die, they do so dramatically, in supernovae that briefly outshine entire galaxies, scattering heavy elements across vast regions of space. But their deaths do not replenish the fuel supply, they consume it. Each supernova is a final expenditure, a last conversion of nuclear potential into light and shock and dispersed matter. What remains after a massive star dies is a neutron star, or a black hole, depending on the mass involved. Neither of these objects produces light in any significant quantity through nuclear fusion. They are remnants, the cold or dark endpoints of stellar processes that have run their course. They persist, but they do not shine in the way stars shine. They are the universe's way of storing mass after the fuel is gone, and they accumulate over time as the stellar population ages and the most massive members die off first. The intermediate stars, stars like the Sun, burn for billions of years before exhausting their hydrogen fuel. When they do, they expand into red giants, briefly becoming far more luminous than they were during their main sequence lives, before shedding their outer layers and leaving behind a white dwarf, a dense, hot remnant roughly the size of Earth, but containing a significant fraction of the original star's mass. White dwarfs do not fuse hydrogen. They are not powered by nuclear reactions. They are simply hot objects cooling in the darkness, radiating away the thermal energy stored in their dense interiors. They cool slowly over billions of years, gradually dimming from white to yellow to orange to red to, eventually, a cold, dark object that emits almost no light at all, a black dwarf. The time scale for a white dwarf to cool into a black dwarf is so long that no black dwarfs are thought to exist yet. The universe is not old enough. The oldest white dwarfs are still warm enough to emit faint light, but in the far future, in a universe that has aged far beyond its current state, the white dwarfs will cool, one by one, over timescales that dwarf the current age of the universe many times over. They will fade. The galaxies that contain them will grow darker. The light that currently makes galaxies visible across billions of light years will diminish, not suddenly, not catastrophically, but steadily, inevitably, as each stellar remnant surrenders its remaining heat to the surrounding darkness. The smallest stars, the red dwarfs, are the most numerous stars in the universe and the most patient. A red dwarf with a fraction of the Sun's mass can burn hydrogen for trillions of years, far longer than the current age of the universe. In the far future, when the Sun has long since become a cooling white dwarf, and the Milky Way has merged with Andromeda, and the resulting galaxy has aged beyond recognition, red dwarfs will still be burning. They will be the last stars, the final embers of the stellar era, burning dimly in an increasingly dark and empty cosmos. But they too will eventually exhaust their fuel. They too will cool and fade. The stellar era of the universe, the era in which nuclear fusion powers light across the cosmos, is not permanent. It has a beginning, a peak, and an end. We are living somewhere in the middle of it, closer to the peak than to the end, but on a trajectory that leads without exception toward the extinction of starlight. Consider what the universe will look like when the last red dwarf has burned out, not immediately after, but in the long aftermath. The galaxies, or what remains of them after billions of years of mergers and interactions, will be populated almost entirely by stellar remnants, white dwarfs cooling toward black dwarfs, neutron stars spinning in the darkness, black holes, the most massive remnants of all, sitting at the centers of galaxies and scattered throughout their volumes, their gravity still active, still pulling matter toward them, still growing slowly as they accrete whatever sparse material drifts within their reach. The galaxies will not be empty, they will be full of objects, but those objects will produce almost no light. The universe will be dark in a way it has never been dark before, not the darkness of the voids between filaments, but the darkness of dead galaxies, of stellar graveyards, of matter that has exhausted its capacity to shine. This is the transition from the stelliferous era, the age of stars, to what cosmologists sometimes call the degenerate era, the age of stellar remnants. It is a transition that will take place over timescales so vast that they are almost impossible to hold in the mind. The stelliferous era spans roughly from the formation of the first stars, a few 100 million years after the Big Bang, to the death of the last red dwarfs, perhaps 100 trillion years from now. 100 trillion years. The current age of the universe is approximately 13.8 billion years. 100 trillion years is more than 7,000 times longer than the universe has currently existed. And yet on the full timescale of the universe's future, the stelliferous era is not the longest chapter. It is not even close to the longest chapter. The degenerate era, the age of cooling white dwarfs and silent neutron stars and slowly accreting black holes, will last far longer. The cooling of white dwarfs into black dwarfs alone will take on the order of 10 to the power of 37 years, a number so large that writing it out in full would require more digits than there are atoms in the observable universe. During this era, the universe will be almost entirely dark. The only light will come from occasional collisions between stellar remnants, from the rare accretion of matter onto neutron stars or black holes, from the faint glow of the warmest remaining white dwarfs. These events will be sparse, separated by vast intervals of darkness and silence. The universe will not be dead, in the sense that matter will still exist and physical processes will still occur, but it will be profoundly, almost absolutely dark, and it gets worse, because even the stellar remnants are not permanent. Even the cold, dark objects that survive the death of the stars are subject to physical processes that will, over unimaginable timescales, cause them to change, to decay, to dissolve. Protons, the fundamental building blocks of atomic nuclei, may not be stable forever. Certain theoretical frameworks in physics predict that protons have a finite lifetime, that they will eventually decay into lighter particles through processes that operate on timescales of perhaps 10 to the power of 34 years or longer. If proton decay occurs, then over sufficiently long timescales, all ordinary matter, every white dwarf, every neutron star, every cold rock and frozen ocean, and dark remnant of every planet that ever existed, will dissolve. The atoms will come apart. The nuclei will decay. The matter will convert particle by particle into radiation and lighter particles, and the universe will lose even the cold, dark, silent remnants of its stellar era. The timescale for proton decay, if it occurs, is so long that it makes the current age of the universe seem like an instant. But the universe has time. The universe has more time than any process we can currently imagine requires. And in that time, even the most stable-seeming structures will be subject to the slow, patient arithmetic of physical law. Nothing that exists now is guaranteed to exist in any recognizable form in the deep future. Not the planets, not the stars, not the galaxies, not even the atoms. But there is one class of object that may outlast all of these, one structure that does not depend on nuclear fuel, does not cool and fade like a white dwarf, does not decay like a proton. One object that by its very nature is extraordinarily difficult to destroy, the black hole. In the far future, after the stars have died, and the stellar remnants have cooled and decayed, black holes may be the dominant objects in the universe. Not the only objects, but the most massive, the most persistent, the most structurally significant. They will sit in the centers of what were once galaxies, surrounded by the cold darkness of a universe that has exhausted almost every other form of organized structure. They will continue to grow, slowly, by accreting whatever sparse matter drifts within their gravitational reach. They will merge with each other when their host galaxies merge. They will become, over time, the last great concentrations of mass in the universe, and even they will not last forever. This is perhaps the most counterintuitive and philosophically heavy fact in all of cosmology. Black holes, the objects defined by their ability to trap everything, including light, within their gravitational boundaries, are not truly permanent. They evaporate, not quickly, not in any way that is observable on human timescales or even on the timescales of the stelliferous era, but over timescales that make even the degenerate era seem brief. Black holes lose mass through a process called Hawking radiation, a quantum mechanical effect in which the black hole slowly emits thermal radiation and gradually shrinks. The mechanism behind Hawking radiation involves the quantum nature of empty space, the fact that what we call a vacuum is not truly empty, but is filled with quantum fluctuations, pairs of virtual particles that briefly come into existence and then annihilate each other. Near the event horizon of a black hole, one particle of such a pair can fall into the black hole while the other escapes, and the energy for this process is drawn from the black hole's mass. The result is that the black hole very slowly loses mass, radiating it away as a faint thermal glow. For a stellar mass black hole, the temperature of this radiation is so low and the timescale for evaporation so long that it is completely negligible compared to any other process currently operating in the universe. But in the far future, when the universe has cooled and darkened, and the black hole is the only significant source of anything, Hawking radiation becomes the dominant process. A black hole with the mass of the Sun would take approximately 10 to the power of 67 years to evaporate through Hawking radiation. A supermassive black hole, with a mass billions of times that of the Sun, would take on the order of 10 to the power of 100 years. These are numbers that resist comprehension. They are not large in the way that a billion is large, or even in the way that a trillion is large. They are large in a way that makes every other timescale we have discussed, every era of cosmic history, every age of stars and remnants in decay, seem like a rounding error. And yet, given enough time, even the supermassive black holes will evaporate. They will shrink, they will radiate, and eventually, in a final burst of Hawking radiation as the last of their mass converts to energy, they will be gone. What remains after the last black hole evaporates? This is the question that sits at the end of the universe's timeline, and the answer is not nothing exactly, but it is as close to nothing as physics currently allows. The universe will contain a diffuse, extremely cold gas of fundamental particles and photons, the final products of black hole evaporation and proton decay, and every other process that has operated over the universe's history. These particles will be spread across a space that is unimaginably larger than the observable universe today, because the expansion will have continued for all of those incomprehensible timescales, carrying everything further and further apart. The density of this final state will be so low that the probability of any two particles ever interacting again will be essentially zero. The temperature will be so close to absolute zero that the distinction between the universe and true emptiness will be almost philosophical. This is what physicists call heat death, or the final state of maximum entropy. It is not a dramatic ending. There is no explosion, no collapse, no final catastrophe. It is simply the universe reaching a state of such thorough equilibrium, such complete uniformity, such total absence of contrast and gradient and usable energy, that nothing further can happen, not because the laws of physics have changed, not because matter has been destroyed in any fundamental sense, but because the universe has exhausted every available difference, every gradient between hot and cold, dense and sparse, ordered and disordered, that could drive any further process. The universe will not end. It will simply stop being capable of change. Entropy is the measure of this exhaustion. It is the measure of how thoroughly the available energy in a system has been distributed, how completely the differences that allow work to be done have been smoothed out. A universe with low entropy is a universe with sharp contrasts, with hot regions and cold regions, with dense concentrations and empty voids, with the kind of disequilibrium that drives stars to burn and planets to form, and chemistry to occur and life to metabolize. A universe with high entropy is a universe where those contrasts have been erased, where the energy is spread so uniformly that no process can extract useful work from it, where the temperature is the same everywhere, and the density is the same everywhere, and nothing can happen because there is no difference left to exploit. The universe began in a state of extraordinarily low entropy. The Big Bang produced conditions of extreme density and temperature, but also of remarkable order in certain respects, conditions that allowed the subsequent evolution of structure, complexity, and contrast. Every process that has occurred since then, every star that has burned, every galaxy that has formed, every supernova that has exploded, every black hole that has accreted matter, has increased the total entropy of the universe. The universe has been moving toward higher entropy since the moment of its beginning. and it will continue moving in that direction until it reaches the maximum possible entropy, the state of heat death, from which no further increase is possible because no further process can occur. This is not a hypothesis. It is a consequence of the second law of thermodynamics, one of the most thoroughly tested and universally applicable principles in all of physics. The second law does not say that entropy always increases everywhere locally. It says that the total entropy of a closed system always increases or remains constant. The universe is, by definition, the ultimate closed system. There is nothing outside it to exchange entropy with, and so the total entropy of the universe increases, always, without exception, without reversal, without any mechanism that could run the process backward. The stars burn because there is a difference between the dense, hot core of a star and the cold, sparse space surrounding it. That difference drives the nuclear reactions that produce light and heat, but the light and heat radiated by the star increase the entropy of the universe. The star is converting a low-entropy state, concentrated nuclear fuel, into a higher entropy state, diffuse radiation and heavier elements. The star is beautiful and extraordinary, and the source of almost all the energy that drives complexity in the universe, and it is, in the thermodynamic sense, a machine for increasing entropy. Every star that shines is moving the universe one step closer to the final equilibrium. This does not make the stars less magnificent. It does not make the complexity they enable less real or less remarkable, but it places that magnificence in a context that is difficult to ignore once you have seen it. The universe is not simply a place where things exist. It is a place where things exist temporarily, driven by the energy released as the universe moves from its initial low-entropy state toward its final high-entropy state. The complexity, the structure, the light, the life, all of it is a consequence of that transition, and the transition has a direction, and the direction leads to silence. Place yourself, in thought, inside a galaxy in the far future. Not the immediate future, not a billion years from now, but the deep future, a time so remote that the current age of the universe is a negligible fraction of the elapsed time. The galaxy around you is dark. The stars that once populated it have long since burned out. The white dwarfs have cooled to black dwarfs, invisible against the surrounding darkness. The neutron stars spin silently, their pulsed emissions too faint and too infrequent to illuminate anything. At the center of the galaxy, a supermassive black hole sits in the darkness, its presence detectable only by the gravitational distortion it imposes on the sparse matter around it and the faint cold glow of Hawking radiation it emits. The space between the remnants is vast. The galaxy is not empty in the way the cosmic voids are empty, because it still contains matter, still has structure, still has the gravitational coherence that keeps it bound together against the expansion of the universe. But it is dark in a way that the current universe is not. There are no supernovae lighting up the interstellar medium. There are no young, hot stars blazing blue-white in stellar nurseries. There are no planetary systems forming in the warm glow of newly ignited suns. There is only the cold, dark, patient waiting of matter that has exhausted its capacity to shine. And beyond the galaxy, the darkness is even more complete. The accelerating expansion has long since carried every other galaxy beyond the cosmic horizon. The local group, the gravitationally bound collection of galaxies that includes the Milky Way and Andromeda and their smaller companions, has merged into a single, aging, darkening elliptical galaxy. But beyond that merged remnant, there is nothing visible. The universe beyond the horizon is not empty, in the sense that matter still exists there, that other merged galaxy remnants still persist in their own isolated darkness. But it is unreachable. It is causally disconnected. It is, for all practical and theoretical purposes, a different universe, one that can never exchange information or matter or energy with the island of remnants that constitutes the observable cosmos of that distant era. The isolation is total, not the isolation of distance which can in principle be crossed given enough time and technology, but the isolation of an expanding space-time that has permanently severed the causal connections between regions that were once, in the early universe, in contact with each other. The universe has not only expanded, it has fragmented in the causal sense into islands of matter separated by an ever-growing ocean of space that no signal can cross. Each island is alone. Each island is aging. Each island is moving at its own pace toward the same final state of cold, dark, structureless equilibrium. There is something in this picture that goes beyond the merely physical, something that touches on the nature of knowledge, of memory, of the possibility of understanding. The universe in its current state contains within it the evidence of its own history, The cosmic microwave background carries information about the conditions of the early universe. The large-scale structure of the cosmic web carries information about the processes that shaped it. The chemical composition of stars carries information about the nucleosynthesis that produced the elements. The light from distant galaxies carries information about the state of the universe billions of years ago. The universe is, right now, a record of itself, a physical archive of its own past, written in light and matter and the geometry of space. That archive is being erased, not deliberately, not by any process that targets information specifically, but by the same physical processes that are driving the universe toward heat death. The expansion carries the evidence beyond the horizon. The cooling of stellar remnants destroys the thermal gradients that encode information about stellar processes. The evaporation of black holes converts the information about everything that fell into them into a diffuse, nearly featureless thermal radiation that may or may not preserve that information in any recoverable form. The increase in entropy smooths out the contrasts and structures that carry information, replacing them with uniformity and equilibrium. The universe is forgetting itself, and the rate of forgetting is accelerating, driven by the same dark energy that is accelerating the expansion, driven by the same entropy that is driving every physical process toward equilibrium. The window during which the universe is readable, during which its history is accessible to any observer within it, is not permanent. It is a phase, a temporary condition of the universe's middle age, and it is passing. We are inside that window. Right now, at this moment, the universe is still readable, the evidence is still present, the archive is still open, the cosmic microwave background is still detectable, the large-scale structure is still mappable. The history of the universe is still written in the sky in a language that, with sufficient effort and ingenuity, can be read. This is not a permanent condition. It is a gift of timing, an accident of our position in cosmic history, and it will not last. The night sky that you see when you look upward is not simply beautiful. It is evidence. It is a physical record of processes that occurred over billions of years, written in light that has traveled across unimaginable distances to reach your eyes. Every photon that arrives from a distant star or galaxy is a message from the past, a piece of information about the state of the universe at the moment that photon was emitted. The night sky is an archive, and you are reading it whether you know it or not simply by looking. But the archive is finite. The messages are arriving, but the sources are receding. The light from the most distant galaxies is already the last light we will ever receive from them, because the light they are emitting now will never reach us. The archive is not being added to. It is being slowly closed page by page, as each distant source crosses the horizon, and its future emissions become permanently unreachable. What we see now is not a snapshot of the current universe. It is the last transmission from a universe that is in the process of becoming unreachable. And this leads to the final, most disturbing implication of everything that has been laid out here. Not the size of the universe, not the emptiness of the voids, not the invisibility of dark matter, not the acceleration of expansion, not the death of stars, not the evaporation of black holes. All of those things are disturbing in their own ways, and they are all real, and they all matter. But the deepest implication, the one that sits underneath all the others and gives them their full weight, is this. The universe is not a stable backdrop against which events occur. It is itself a process moving in a specific direction toward a specific endpoint, and that endpoint is the permanent, irreversible elimination of the conditions that make observation, knowledge, complexity, and meaning possible. The universe is not indifferent to life and intelligence in the way that a rock is indifferent to the moss growing on it. It is indifferent in a more thorough sense. It is structured in such a way that the conditions for life and intelligence are temporary, local, and vanishingly rare against the full backdrop of cosmic space and time. The stelliferous era, the age of stars during which the energy gradients exist that can drive chemistry and metabolism and thought, is a brief interval in a much longer story. Before it, the universe was too hot and too dense for complex chemistry. After it, the universe will be too cold and too dark and too diffuse for any process requiring energy gradients to operate. The window is narrow. We are inside it, and it is closing. This is not a reason for despair in any simple sense. It is not a message about the value or meaning of existence within that window. It is simply a description of what the universe is and what it is doing. But it is a description that changes the texture of everything else. The stars are not permanent fixtures. They are temporary processes. The galaxies are not eternal structures. They are aging systems. The observable universe is not a fixed stage. It is a shrinking island of accessible information in an expanding ocean of unreachable darkness. And the darkness is winning, not because it is malevolent, not because it is the enemy of anything, but simply because it is the direction in which the physics of this universe points. The emptiness you felt at the beginning of this investigation, the emptiness of the night sky, the emptiness of the cosmic voids, the emptiness of the space between galaxies and between stars and between atoms, was not the full picture. It was the beginning of the picture. The full picture includes not only the emptiness of space but the emptiness of time, the vast stretches of cosmic future during which the universe will contain matter but no light, structure but no warmth, objects but no processes capable of complexity or knowledge or change. The universe is not merely empty in space. It is becoming empty in time, moving toward a future in which the word empty will need to be redefined to capture a condition more thorough and more final than anything the current universe contains. There is a particular quality to the silence that awaits the universe in its final eras, a quality that is different in kind from any silence we can experience or imagine from within the current cosmos. The silence of a remote mountain at midnight is still filled with the faint sounds of wind and biology, and the distant hum of a civilization somewhere over the horizon. The silence of deep space, as experienced by any hypothetical traveler moving between galaxies, is still a silence that exists within a universe actively producing light and heat, and gravitational waves, and the constant background radiation of the cosmic microwave field. Even the deepest silence available to us now is a silence within a living universe, a universe still burning, still expanding into its middle age, still rich with the energy gradients that make processes possible. The silence of the degenerate era will be different. It will be a silence in which the universe has not merely quieted, but has exhausted the mechanisms by which it generates sound and light and heat in any meaningful quantity. The black dwarfs will sit in the darkness without radiating anything detectable at cosmological distances. The neutron stars will spin down, their rotational energy slowly dissipating, their pulsar emissions fading as their magnetic fields weaken over trillions of years. The black holes will emit their Hawking radiation, but that radiation will be so cold, so close to absolute zero in temperature, that it will be indistinguishable from the background temperature of the universe itself, which will also be approaching absolute zero as the expansion continues to cool the cosmic microwave background toward nothing. The universe will be in a state of near-perfect thermal equilibrium with itself, not because everything has been destroyed, but because everything has been equalized. The temperature difference between the interior of a black dwarf and the surrounding space will be negligible. The temperature difference between the vicinity of a black hole and the empty space far from it will be negligible. The gradients that drive processes, the differences that make things happen, will have been smoothed to the point where the universe is, for all practical purposes, a uniform, cold, dark, featureless expanse of matter and radiation in equilibrium. And yet, even in this state, the universe will not be truly static. There will still be quantum fluctuations, the irreducible randomness of the quantum vacuum that cannot be eliminated, even at absolute zero. There will still be the occasional quantum tunneling event, the rare and improbable process by which a particle crosses an energy barrier that classical physics would say is impassable. Over timescales so vast that they make the evaporation time of a supermassive black hole look brief, quantum fluctuations could, in principle, produce spontaneous rearrangements of matter. A Boltzmann brain, a hypothetical self-aware structure that arises by pure chance from the random fluctuations of a high-entropy universe, is one of the more unsettling thought experiments that emerges from this territory. Not because it is likely, but because in a universe with infinite time, even the vanishingly improbable becomes, in some sense, inevitable. But these are not processes that restore the universe to a state of complexity or meaning in any sustained way. A quantum fluctuation that briefly produces a structured arrangement of matter will be followed, with overwhelming probability, by the immediate dissolution of that structure back into the surrounding equilibrium. The universe does not reverse its entropy through quantum fluctuations. It merely flickers occasionally and randomly against a background of near-total uniformity. The flickers are not a reprieve. They are a reminder that even in the deepest silence, the laws of physics continue to operate, indifferent to whether anything is present to observe them. This is the condition toward which the universe is moving, not destruction, not collapse, not a dramatic final event that brings everything to a close. Simply the gradual, patient, mathematically inevitable approach to a state of maximum entropy, minimum contrast, minimum usable energy, and minimum capacity for change. The universe will not end with a bang or a whimper. It will end with an equilibrium so thorough that the distinction between ending and continuing becomes meaningless. But it goes deeper, because the approach to heat death is not the only trajectory the universe is following simultaneously. The accelerating expansion is also continuing, and it is continuing on a timescale that intersects with the thermodynamic trajectory in ways that compound the isolation and the darkness. As the universe expands, the density of matter decreases. The average distance between any two particles increases. The probability of any two particles interacting decreases. The universe becomes not only thermodynamically exhausted, but geometrically dispersed, spread across a volume so vast that even the cold, dark remnants of the stellar era are separated by distances that make the current cosmic voids look intimate. The cosmic voids of the present universe, those vast, nearly empty regions hundreds of millions of light-years across, are structures within a universe that still has a cosmic web, still has filaments and walls and clusters, still has a large-scale structure that organizes matter into concentrations separated by emptiness. In the far future, that structure will be gone. The gravitationally bound systems, the merged galaxy remnants and their populations of stellar remnants and black holes, will persist as islands. But the cosmic web itself, the filaments and walls that currently define the large-scale structure of the universe, will have been dissolved by the expansion. The matter in those structures will have been pulled into the gravitationally bound islands or dispersed into the expanding void. The architecture of the cosmic web, the structure that took billions of years to build from the initial conditions of the universe, will be erased by the expansion that dark energy drives. What remains will be islands, isolated, gravitationally bound remnants of what were once galaxy clusters or superclusters, separated by expanding voids that are no longer bounded by filaments and walls, but simply extend in every direction to the limits of the observable universe, which will itself be shrinking as the expansion carries more and more of the cosmos beyond the horizon. The islands will not be able to communicate with each other. They will not be able to exchange matter or energy or information. They will each age independently, following the same thermodynamic trajectory toward heat death, but doing so in complete isolation from every other island. Each island will eventually be dominated by its central black hole, or by a collection of black holes that have merged over the eons. The black hole will slowly accrete the remaining matter in the island, growing slightly as it does so, until the supply of accreting matter is exhausted. Then it will sit in the darkness, evaporating through Hawking radiation at a rate so slow that the temperature of its radiation is lower than the temperature of the surrounding space. It will not even be evaporating efficiently, because the surrounding space is warmer than the Hawking temperature of a sufficiently massive black hole. It will wait, in a sense, for the universe to cool further, for the background temperature to drop below its Hawking temperature, before it begins to lose mass faster than it gains it from the surrounding radiation. And then, over timescales that are to the current age of the universe, as the current age of the universe is to a single Planck time, the smallest meaningful unit of time in physics, the black hole will evaporate. It will shrink. Its Hawking temperature will rise as its mass decreases, because smaller black holes are hotter in the Hawking sense. The evaporation will accelerate as the black hole shrinks, ending in a final burst of high-energy radiation as the last of the black hole's mass converts to energy, and then it will be gone. The island will contain nothing but the diffuse products of that final evaporation, spread across a space that is itself expanding, diluting those products further with every passing moment. This is the end of the black hole era. This is the moment, or rather the extended process spanning incomprehensible timescales, after which the universe contains no more black holes, no more significant concentrations of mass, no more objects with the gravitational influence to organize matter, or drive any process more complex than the random thermal motion of individual particles. The universe will be at this point as close to truly empty as it is possible to be, while still containing matter and energy. The particles will be there, the photons will be there, but they will be so sparse, so cold, so thoroughly separated by the expansion of space, that the probability of any two of them ever interacting again will be, for all practical purposes, zero. Place yourself, in thought, in this final era, not as a physical being, because no physical being could exist in these conditions, but as an observer, a hypothetical presence capable of perceiving the state of the universe without being subject to its thermodynamic constraints. What you would perceive is not darkness in the way we usually mean the word. It is something more absolute. The photons from the final black hole evaporations are present, but they are so redshifted by the expansion of the universe that their wavelengths are longer than the observable universe was at the time of their emission. They are not light in any meaningful sense. They are a faint, cold, structureless radiation field, indistinguishable from the quantum noise of the vacuum. The particles, the electrons and positrons and neutrinos and whatever other stable fundamental particles the laws of physics permit, are present but separated by distances so vast that the concept of distance itself becomes almost meaningless. There is no structure, there is no gradient, there is no difference between one region of space and another that could drive any process. The universe is, in the thermodynamic sense, dead, not destroyed, not absent, simply incapable of change in any direction that increases complexity or contrast or the conditions for anything we would recognize as an event. And the expansion continues. Even in this final state, space continues to expand. The distances between the last particles continue to grow. The universe continues to become larger and emptier and colder and more uniform. There is no endpoint to the expansion, no moment at which it stops and the universe reaches a final static state. The expansion is driven by dark energy, and dark energy, as far as we can determine, does not diminish with time. It does not dilute as the universe expands, the way matter and radiation dilute. It is a property of space itself, and as space expands, the total amount of dark energy increases proportionally. The expansion accelerates forever, and the universe grows forever, and the particles within it are separated forever by distances that increase without limit. This is the condition that the word emptiness was always pointing toward without quite reaching it. The emptiness of the cosmic voids, the emptiness of the space between galaxies, the emptiness of the interstellar medium, all of these are rich and structured compared to the emptiness of the final universe. They are emptiness with context, emptiness surrounded by structure, emptiness that is defined by its relationship to the matter and energy that bound it. The final emptiness has no context. It has no surrounding structure. It is not the absence of something that exists nearby. It is the universal condition, the state of everything, the only remaining fact about a universe that has exhausted every other fact about itself. There is a question that this picture raises, one that is not strictly scientific, but that the science makes unavoidable. If the universe is moving toward this final state, if the trajectory is clear and the end point is determined by the laws of physics operating on the initial conditions of the cosmos, then what does it mean that we are here, now, in the middle of it? What does it mean that matter arranged itself in one small corner of one ordinary galaxy into structures capable of perceiving the universe, measuring it, mapping it, and understanding, at least in outline, where it is going? The question is not rhetorical. It is not an invitation to find comfort in the fact of consciousness or to derive meaning from the ability to understand. It is a genuine puzzle, and the puzzle has an unsettling edge. The universe did not need to produce observers. The laws of physics that govern the cosmic web and dark matter and dark energy and entropy do not require, anywhere in their structure, the existence of anything capable of awareness. The universe would be doing exactly what it is doing, expanding and cooling and aging toward heat death, whether or not anything inside it had ever developed the capacity to notice. And yet something did develop that capacity. Something arose, in the narrow window of the stelliferous era, in the brief interval when energy gradients were steep enough, and chemistry was rich enough, and time was long enough for complexity to bootstrap itself into awareness. Something looked at the universe and began to ask questions about it. And the answers to those questions, assembled over centuries of observation and measurement and theoretical work, have produced a picture of the universe that is, in its broad outlines, deeply and irreversibly unsettling. The universe is not a home. It is not a stage. It is not a backdrop designed for the drama of existence. It is a physical system evolving according to physical laws toward a physical endpoint, and the existence of observers within it is a local, temporary, improbable fluctuation in a system that is overwhelmingly dominated by processes that have nothing to do with observation or awareness or meaning. The observers are real, their perceptions are real, their understanding is real, but they are not the point. There is no point, in the teleological sense. There is only the process, and the process is indifferent to whether it is observed. This is not nihilism. It is not a claim that nothing matters, or that understanding is worthless. It is simply a description of the relationship between observers and the universe they inhabit, a relationship that is asymmetric in a way that the universe's scale and trajectory make impossible to ignore. The universe does not need us. We need it, in the most literal sense, because we are made of it and sustained by it and will eventually be dissolved back into it. But the need is entirely one-directional. The universe will proceed toward heat death whether we understand it or not. whether we exist or not, whether anything capable of awareness ever arose within it or not. And this leads to something more disturbing still. Because the ability to understand the universe, the capacity for cosmological knowledge that has produced everything described in this investigation, is itself subject to the same thermodynamic constraints as everything else. The minds that do cosmology are physical systems. They require energy gradients to operate. They require the kind of organized low-entropy matter that only exists during the stelliferous era. They require stars and planets and the chemical complexity that stellar nucleosynthesis makes possible. They are, in the thermodynamic sense, temporary structures sustained by the same energy flows that will eventually be exhausted. The knowledge that has been accumulated, the understanding of dark matter and dark energy and cosmic voids and the large-scale structure and the fate of the universe, exists in physical form. It is encoded in the physical states of brains and books and electronic storage media and the cultural transmission systems that carry information from one generation to the next. It is real knowledge, and it is genuinely about the universe, and it is as accurate as the measurements and theories that produced it. But it is encoded in matter, and matter is subject to entropy, and entropy increases, and the physical systems that carry this knowledge will eventually be dissolved by the same processes that will dissolve everything else. The universe will not remember that it was understood. There is no cosmic archive in which the knowledge accumulated by any civilization is preserved against the increase of entropy. The understanding exists now, in the physical states of the systems that carry it, and it will persist as long as those systems persist, and then it will be gone. Not because it was wrong, not because it was incomplete, but because the physical substrate that carries it will be dissolved by the thermodynamic processes that govern all matter in an aging universe. Future civilizations, if they arise in the far future, will not inherit this understanding. They will not find it written in the sky because the sky will be dark. They will not find it encoded in the cosmic microwave background because that signal will be undetectable. They will not find it in the large-scale structure of the universe because that structure will have been erased by the expansion. They will start from scratch, in a universe that has hidden its own history, and they will build whatever understanding they can from the impoverished evidence available to them in their era. And that understanding will be incomplete in ways they cannot know, because the evidence that would complete it will be permanently beyond their reach. We are not in that position. We are in the position of having access to the evidence, of living in the era when the universe is still readable, when the archive is still open, when the history is still written in the sky. That position is not permanent. It is not guaranteed. It is a consequence of our location in cosmic time, our existence during the brief window when the stelliferous era is still ongoing and the expansion has not yet carried the evidence beyond the horizon. We are, in a very real sense, the universe's ability to understand itself, and that ability is temporary. The night sky, seen with this understanding, is not the same as the night sky seen without it. The stars are not simply beautiful, they are burning through fuel that will not be replenished. The galaxies visible in deep-field images are not simply distant, they are receding beyond the horizon, their future light already lost to us. The cosmic microwave background, that faint glow of ancient radiation that fills the sky in every direction, is not simply a relic of the early universe. It is a message that is becoming harder to read with every passing era, a signal that will eventually be redshifted beyond any possible detection, carrying with it the last direct evidence of the universe's origin. The darkness between the stars is not empty. It is full of the invisible architecture of dark matter, the expanding fabric of space-time driven by dark energy, the cold remnants of processes that have already run their course, and the faint, ancient light of objects so distant that the universe has changed significantly since that light was emitted. The darkness is not the absence of the universe. It is the universe, in its dominant form, the form that constitutes the overwhelming majority of what exists and what will exist for the overwhelming majority of cosmic time. And the darkness is growing, not in the sense that the stars are going out, though they will, not in the sense that the galaxies are disappearing, though they are, but in the sense that the universe is moving steadily and irreversibly toward a state in which darkness is not merely dominant, but total, a state in which the last sources of light have been extinguished, the last energy gradients have been smoothed, the last structures have been dissolved, and the universe is a cold, dark, uniform, expanding expanse of particles and radiation in equilibrium, incapable of change, incapable of complexity, incapable of anything that could be called an event. That state is not imminent. It is not approaching on any timescale that is relevant to human experience or even to the experience of any civilization that might arise during the stelliferous era. The stars will burn for trillions of years. The universe will remain rich with energy and structure, and the possibility of complexity for longer than any number we use in ordinary life can convey. But the direction is set, the trajectory is determined, the endpoint is not in doubt, and the endpoint is silence. Not the silence of a room after the music stops, not the silence of a landscape after a storm, not the silence of space, as we currently understand it, filled with the invisible hum of radiation, and the gravitational whisper of dark matter, and the quantum noise of the vacuum. The silence of the final universe will be the silence of a system that has reached equilibrium, that has no more differences to resolve, no more gradients to exhaust, no more processes to run. It will be the silence of completion, in the most terrible sense of that word. The universe will have finished, not ended, finished, and there will be nothing left to begin. And yet the silence is not the strangest part. The strangest part is what precedes it, the long, slow, almost geological process by which the universe transitions from its current state of relative richness to that final equilibrium. Because the transition is not a single event or a series of dramatic catastrophes. It is a sequence of diminishments, each one leaving the universe slightly less capable than it was before, each one closing off a possibility that had previously been open, each one making the universe a slightly smaller, slightly darker, slightly more constrained version of what it had been. The universe does not fall into silence. It settles into it, the way a fire settles into ash, not with a final extinguishing moment, but through the gradual exhaustion of everything that was burning. Consider the loss of star formation not as an astronomical fact, but as an existential transition. The moment the last star ignites in the universe, the last time gravity pulls a cloud of gas to sufficient density and temperature for nuclear fusion to begin, is the moment the universe loses one of its most fundamental capacities, the capacity to create new sources of light and heat and the heavy elements that make chemistry possible. After that moment, the universe can only work with what it has. It can rearrange its existing matter. It can allow its existing stars to burn through their remaining fuel. It can watch its existing stellar remnants cool and fade, but it cannot make anything new in the stellar sense. The creative phase of the universe's history, the phase in which new stars and new planetary systems and new opportunities for chemistry and complexity are continuously being generated, will be over. We do not know exactly when that moment will come. The last red dwarfs will burn for trillions of years, and as long as there is gas available to collapse, new red dwarfs will form. But the gas supply is finite, and the rate of star formation has been declining for billions of years, and the trajectory leads to a final star, a last ignition, a closing of the stellar era. That star will not be marked by any ceremony. It will not be observed by anything in all probability because the universe will be so old and so dark by then that the probability of any observer existing to witness it will be vanishingly small. It will simply ignite, burn for its allotted time, and go out. And after it goes out, no new star will ever replace it. The loss of star formation is followed, over subsequent trillions of years, by the loss of the stars themselves. The most massive red dwarfs will burn out first, leaving white dwarfs that begin their long cooling. The least massive red dwarfs, the most patient and the most numerous, will burn longest, their dim red light, the last stellar illumination in an increasingly dark universe. When the last red dwarf exhausts its hydrogen and begins its transition to a white dwarf, the stelliferous era ends not with a dramatic finale, but with the quiet dimming of the universe's last active star. The light does not go out all at once. It fades, star by star, over trillions of years, until the last one is gone and the universe is left with only the cooling remnants of what it once was. But it goes deeper, because the loss of starlight is not only a physical transition, it is an informational one. Stars are not merely sources of light and heat. They are the engines of chemical complexity. The nuclear fusion that powers stars produces the heavy elements, the carbon and oxygen and nitrogen and iron, and all the other elements beyond hydrogen and helium that make chemistry rich and varied and capable of producing the molecular complexity that life requires. When stars die, they scatter these elements into the interstellar medium, enriching the gas clouds from which new stars and planets form. The cycle of stellar birth and death is also a cycle of chemical enrichment, a process by which the universe gradually builds up its inventory of complex chemistry. When star formation ends, that cycle ends with it. The chemical enrichment of the universe stops. The inventory of heavy elements is fixed at whatever level it has reached by the time the last star forms. And as the universe ages further, as the stellar remnants cool and the matter disperses, even that inventory becomes less accessible, locked up in cold, dark objects, separated by expanding voids. The chemistry that makes complexity possible does not disappear immediately, but it becomes progressively less available, less concentrated, less capable of driving the reactions that build complex molecules. The universe loses not only its light, but its chemical richness, its capacity for the kind of molecular diversity that underlies everything we recognize as complex. This chemical impoverishment is one of the less discussed aspects of the universe's long-term future, but it is one of the most consequential. We tend to think of the universe's capacity for life and complexity as a function of energy availability, and energy availability is certainly central, but it is also a function of chemical availability, of the presence of the right elements in the right concentrations in the right environments. As the universe ages and its matter disperses, and its chemistry becomes less accessible, the conditions for complexity become not only energetically constrained but chemically constrained. The universe becomes less capable of building interesting things not only because it is running out of energy, but because it is running out of the organized chemical environments in which interesting things can be built. Place yourself, in thought, at the boundary between the stelliferous era and the degenerate era, not at the exact moment of the last star's ignition, but in the long twilight that precedes it, the era when star formation has slowed to a trickle, when the galaxy is populated mostly by aging red dwarfs and the cooling remnants of earlier stellar generations, when the interstellar medium has been largely consumed and the gas clouds that once birthed stellar nurseries have been depleted. The galaxy is not dark yet. There is still light. But the light is dim and red and sparse, the light of old, cool stars burning through the last of their fuel with the patience of objects that have been burning for longer than the current age of the universe. The sky from a hypothetical planet in this twilight era would be profoundly different from the sky we see now. The brilliant blue-white stars that currently dominate the upper end of the stellar luminosity function would be long gone, their lifetimes measured in millions of years already exhausted billions of years earlier. The yellow stars like the sun would be gone, their 10 billion-year lifetimes spent. What remains would be the red dwarfs, dim and cool, their light more infrared than visible, their surfaces barely warm enough to glow in the wavelengths that human eyes evolved to detect. The galaxy would look, to eyes like ours, almost dark, not completely dark, but dark in the way that a fire looks dark when it has burned down to the last few coals, still glowing, still warm, but no longer capable of illuminating anything beyond its immediate vicinity. And beyond the galaxy, the darkness would be more complete. The accelerating expansion would have long since carried most of the currently observable universe beyond the cosmic horizon. The local group, merged into a single aging elliptical remnant, would be the entire observable universe for any civilization existing in that era. The cosmic web, the filaments and walls and voids that currently define the large-scale structure of the cosmos would be invisible, its constituent galaxies either merged into the local remnant or carried beyond the horizon. The universe would appear to any observer in that era to consist of a single aging galaxy surrounded by absolute darkness. That observer, if it existed, would have no way of knowing that the universe had once contained hundreds of billions of galaxies. It would have no way of knowing that those galaxies had been organized into a vast cosmic web of filaments and voids. It would have no way of knowing that the universe had once been filled with the light of trillions of stars burning simultaneously across billions of light years. The evidence for all of that would be gone, carried beyond the horizon by the expansion, redshifted into undetectability by the cooling of the universe, dissolved by the entropy that had been increasing since the beginning. The observer would look at the sky and see a single dim galaxy in an ocean of darkness, and it would have no reason to suspect that the darkness had once been full of light. This is the cosmic amnesia that accelerating expansion produces, not the forgetting of a mind, but the forgetting of a universe, the systematic erasure of the evidence of its own history by the physical processes that govern its evolution. The universe does not choose to forget. It simply expands and cools and ages, and in doing so it moves its own past beyond the reach of any future observer. The history is not destroyed. The events happened. The galaxies existed. The stars burned. But the record of those events, the light and radiation and structural information that carries the history of the universe, is dispersed and redshifted and carried beyond the horizon until it is effectively inaccessible. There is something in this that goes beyond the merely physical, and touches on something more fundamental about the nature of information and reality. We tend to assume, implicitly, that the past is permanent, that what has happened, and that its having happened is a fact that persists regardless of whether anyone can access the evidence. And in a strict logical sense, that is true. The galaxies that existed before the horizon swallowed them did exist. The stars that burned during the stelliferous era did burn. The events of the early universe did occur. But in a physical sense, in the sense that matters for any observer trying to understand the universe from within it, the past becomes inaccessible in a way that is functionally equivalent to its not having happened. If no evidence of an event can ever be retrieved, if no measurement can ever detect its consequences, if no observation can ever confirm its occurrence, then in what sense does its having occurred remain a meaningful fact? This is not a philosophical trick. It is a genuine consequence of the physics of an expanding universe with a cosmic horizon. The events beyond the horizon are real, but they are real in a way that is permanently disconnected from any observer on this side of the horizon. Their reality is, in the most practical sense, irrelevant to the universe as it can be known from within the observable region. The universe is not only becoming emptier and darker, it is becoming less real, in the sense that the portion of reality accessible to any observer is shrinking, and the portion that is permanently beyond reach is growing. And this process is not limited to the cosmic horizon created by dark energy. It operates at every scale where information becomes inaccessible. The information about what fell into a black hole is, according to some interpretations of physics, lost when the black hole evaporates. The Hawking radiation that carries away the black hole's mass does not, in the standard semi-classical calculation, carry the information about the specific quantum states of the matter that formed the black hole. That information may be scrambled beyond any practical recovery, or it may be genuinely destroyed, depending on which interpretation of quantum gravity turns out to be correct. The question of whether black hole evaporation destroys information is one of the deepest unresolved problems in theoretical physics, and its resolution has implications not only for black holes, but for the fundamental nature of physical law. If information is genuinely destroyed in black hole evaporation, then the universe is not merely becoming less accessible, it is becoming less complete. The total information content of the universe would decrease over time, as black holes form and evaporate and carry their informational content into a form that cannot be recovered. The universe would be not only expanding and cooling and aging, but also, in a fundamental sense, forgetting, not metaphorically, literally. The physical information encoded in the quantum states of matter would be reduced, irreversibly, by the process of black hole formation and evaporation. Most physicists believe that information is conserved, that the Hawking radiation from an evaporating black hole does carry the information about what fell in, encoded in subtle correlations in the radiation that are in principle recoverable, even if in practice they are impossibly scrambled. This is the position implied by the holographic principle, and by certain results in string theory and quantum gravity. But even if information is conserved in this technical sense, the practical accessibility of that information is essentially zero. The correlations in the Hawking radiation that encode the information about the black hole's interior are so subtle, so thoroughly scrambled by the evaporation process, that recovering them would require a computational effort that exceeds anything physically possible. The information is conserved in principle and lost in practice, which is a distinction that matters enormously in theory and not at all in reality. The universe is moving toward a state in which the distinction between conserved and accessible becomes the central fact of existence. The information is there, in some sense, encoded in the quantum states of the particles and radiation that fill the final universe. But it is encoded in a form so thoroughly scrambled, so completely lacking in the structure and contrast that would make it readable, that it might as well not be there. The universe will contain in its final state the complete quantum record of everything that ever happened within it, encoded in the correlations between particles separated by distances so vast that no physical process could ever bring them into contact to allow those correlations to be read. The history of the universe will be present and permanently inaccessible simultaneously. This is the deepest form of the cosmic forgetting, not the loss of information to the horizon, which is a causal disconnection, not the loss of information to black hole evaporation, which is a quantum scrambling, but the loss of information to the expansion itself, the dilution of the quantum record of cosmic history into a state so diffuse and so cold and so thoroughly separated that the record exists but cannot be read by anything, ever, under any circumstances permitted by the laws of physics. The universe will carry its own history within it, and that history will be permanently, irreversibly, completely inaccessible. There is a particular image that captures something of this final condition, not a literal image because the final universe contains almost nothing that could form an image, but a conceptual one. Imagine a library, not a small library, but a library of unimaginable size, containing every book ever written, every thought ever recorded, every measurement ever made, every observation ever noted. Now imagine that library dispersed, not burned, not destroyed, but taken apart page by page, word by word, letter by letter, and each letter sent in a different direction across an expanding space, so that the letters are all still there, all still physically present, but separated by distances so vast that no reader could ever collect enough of them to reconstruct even a single sentence. The library exists, the information exists, but the library is gone, in every sense that matters. That is the final state of the universe's information content. The letters are there, the quantum states are there, the correlations are there, in principle, but the space between them is expanding, and the temperature is approaching absolute zero, and the energy available to drive any process of collection or reconstruction is essentially zero, and the time required to reconstruct anything meaningful from the dispersed record exceeds any time scale on which any physical process could operate. The library is gone. The universe has forgotten everything, not by destroying the record, but by dispersing it beyond any possible recovery, and the expansion continues. Even after the last black hole has evaporated, even after the last particle interaction has occurred, even after the universe has reached its maximum entropy state, the expansion continues. Space continues to grow. The distances between the last particles continue to increase. The universe continues to become larger and emptier and colder, not because anything is driving it toward a new state, but simply because the expansion, once initiated and accelerated by dark energy, has no mechanism to stop. There is no wall at the edge of the universe. There is no boundary where the expansion halts. There is only the continued stretching of space-time, carrying the last remnants of matter and radiation further and further apart into a space that grows without limit and contains, within its growing volume, less and less of anything at all. The ratio of matter to space in the final universe is not merely small, it approaches zero. The universe becomes, in the most literal physical sense, almost nothing, not nothing, because the particles are still there, and the quantum vacuum is still there, and the laws of physics are still operating, but so close to nothing that the distinction requires the precision of quantum mechanics to maintain. The universe will be a near vacuum of near infinite extent, cold beyond any temperature we can meaningfully describe, dark beyond any darkness we can meaningfully imagine, and expanding forever into a future that contains no events, no processes, no changes, no differences, and no observers. This is where the investigation leads, not to a comfortable conclusion, not to a resolution that places the emptiness and the darkness and the entropy in a context that makes them less disturbing, but to the full weight of what the universe is and what it is doing and where it is going. The emptiness of the cosmic voids, the invisibility of dark matter, the acceleration of dark energy, the death of stars, the evaporation of black holes, the increase of entropy, the erasure of information, the expansion into silence. All of these are not separate facts about the universe. They are aspects of a single, coherent, deeply unsettling story about a physical system that began in a state of extraordinary low entropy and is moving, through the operation of its own laws, toward a state of maximum entropy, minimum structure, and permanent silence. The story is not finished. The universe is still in its middle chapters, still burning with the light of trillions of stars, still rich with the energy gradients that make complexity possible, still readable by the observers that have arisen within it during this brief window of cosmic richness. But the direction of the story is not ambiguous. The later chapters have been written by the laws of physics, and they lead, without exception, toward the condition described above. The universe will not be saved from heat death by any process we currently know of. It will not be reversed by any mechanism we can currently imagine. It will proceed, at its own pace, through the stages of its aging, toward the final equilibrium that awaits it at the end of time, and we are here now in the middle of it, aware of it, capable of understanding it, at least in outline, capable of measuring the expansion and mapping the cosmic web and detecting the cosmic microwave background, and calculating the timescales of stellar evolution and black hole evaporation, capable of tracing the trajectory from the Big Bang to the heat death and understanding, with reasonable confidence the broad shape of the universe's story from beginning to end. This capacity for understanding is itself a physical phenomenon, a consequence of the low entropy conditions of the stelliferous era, a temporary property of matter organized into sufficiently complex structures by the energy gradients that the universe currently provides. The understanding will not last. The minds that hold it are temporary. The civilizations that build on it are temporary. The stars that power them are temporary. The universe that contains them is not ending soon, but it is aging, and its aging is in one direction, and that direction does not lead toward more complexity or more richness or more capacity for understanding. It leads toward less, always less. Less light, less heat, less structure, less contrast, less chemistry, less complexity, less awareness, less knowledge, less everything that makes the current universe the extraordinary, improbable, temporary exception to the rule of emptiness and silence that defines the cosmos across most of its history and most of its future. The night sky is not a ceiling, it is not a backdrop, it is not a permanent feature of the universe that will always be there when you look up. It is a phase, a brief, improbable, extraordinarily rich phase in the life of a universe that was dark before the first stars ignited and will be dark again, far more thoroughly and far more permanently after the last stars go out. The light you see when you look at the night sky is not the universe's natural state. It is the universe's exception, its brief departure from the darkness that preceded it and the darkness that will follow it, a temporary illumination of a cosmos that is, in its deepest nature, committed to silence. Look at the night sky with that understanding. Look at the stars not as permanent fixtures but as processes in progress, nuclear furnaces burning through finite fuel on finite timescales, each one a temporary exception to the darkness that surrounds it. Look at the galaxies not as eternal structures but as aging systems, their stellar populations slowly dying, their gas supplies slowly depleting, their light slowly fading over timescales that dwarf human history, but that are, on cosmic scales, brief. Look at the darkness between the stars not as empty space but as the dominant condition of the universe, the state to which everything is slowly returning, the silence into which all the light and heat and complexity of the stelliferous era will eventually dissolve. The universe is not waiting for anything. It is not building toward anything. It is not moving toward a state of greater richness or greater complexity or greater capacity for awareness. It is moving toward equilibrium, toward the maximum entropy state that the second law of thermodynamics guarantees, toward the cold, dark, uniform, expanding silence that is the logical endpoint of a physical system governed by the laws we have measured and the initial conditions we have inferred. The direction is set, the trajectory is determined, the endpoint is not in doubt, and somewhere in the middle of that trajectory, on a small planet orbiting an ordinary star in an unremarkable galaxy, in one of the countless filaments of the cosmic web, something looked up and began to ask questions. Something measured the expansion and mapped the voids and detected the invisible architecture of dark matter and calculated the fate of the stars. Something understood, or began to understand, the full shape of the story it was living inside. Something became, briefly and improbably, the universe's capacity to know itself. That capacity is temporary. The questions it asks will not be answered forever. The understanding it builds will not be preserved against the increase of entropy. The night sky it reads will not remain readable. The window of cosmic richness that makes observation and knowledge and complexity possible is open now, and it will not always be open, and when it closes, it will close permanently, and the universe will continue its expansion into silence without any observer to note the passage, without any record that the window was ever open, without any memory that something once looked up from inside the darkness, and, for a brief moment in the life of an aging cosmos, understood where it was. The questions themselves are worth examining, not the answers which have been laid out across this entire investigation, but the questions, the act of asking them, the impulse that drives a physical system to turn its attention toward the cosmos it inhabits and demand an accounting. Why is the universe so large? Why is it so empty? Why is it expanding? And why is the expansion accelerating? Why does dark matter exist? And what is it? Why does dark energy exist? And what is it? Why did the universe begin in a state of low entropy? Why are the laws of physics the way they are? Why is there something rather than nothing? These questions are not all of equal standing. Some of them have answers, partial or complete, that the science of the last century has produced. The expansion is measured. The acceleration is confirmed. The dark matter is inferred from its gravitational effects with high confidence. The low entropy of the early universe is a fact, even if its ultimate explanation remains contested. But some of the questions have no answers within the current framework of physics, and may not have answers within any framework that physics can construct, because they ask about things that are, by definition, outside the reach of any possible observation or measurement. Why is there something rather than nothing is the deepest of these. It is a question that physics can approach but cannot answer, because any physical answer presupposes the existence of the laws of physics, which are themselves something rather than nothing. Any explanation of why the universe exists requires a framework within which the explanation operates, and that framework is itself part of the something that needs to be explained. The question does not have a bottom. It recedes infinitely, each answer generating a deeper version of the same question, until the questioner is left not with an answer, but with the bare fact of existence, unexplained, and perhaps inexplicable. This is not a failure of science. It is a boundary condition of knowledge itself, a limit that is not imposed by the inadequacy of our instruments or the incompleteness of our theories, but by the structure of explanation as such. Explanations explain things in terms of other things. At some point, the chain of explanation must either terminate in something that is taken as given, something that simply is without further explanation, or it must loop back on itself in a way that is circular and therefore not truly explanatory. The universe, at its deepest level, may simply be the thing that is taken as given, the brute fact at the bottom of the chain, the something that exists without explanation because explanation requires something to exist before it can operate. But here is what makes that unsettling in a way that goes beyond the merely philosophical. The universe that exists, the one we have been investigating throughout this entire account, is not a comfortable or a hospitable or a human-scaled thing. It is vast beyond comprehension, empty beyond imagination, aging toward a silence that will be more complete and more permanent than any silence that has ever existed within it. If the universe is the brute fact at the bottom of the chain of explanation, if it is the something that simply is, then what simply is this: a physical system of incomprehensible scale and age, governed by laws that produce complexity only as a temporary local exception to a universal trend toward disorder, moving inexorably toward a final state in which nothing happens and nothing can happen, and nothing will ever happen again. That is what exists. That is the brute fact. Not a universe designed for observers. Not a universe tending toward greater richness or greater meaning. Not a universe in which the existence of awareness is anything other than a temporary accident of thermodynamics. A universe that is, in its overwhelming majority by volume and by time, cold and dark and empty and silent, with a brief, narrow, improbable exception during which energy gradients are steep enough and chemistry is rich enough for complexity to arise, and within that exception, an even briefer and even more improbable sub-exception during which that complexity becomes aware of itself and begins to ask questions about the system it inhabits. The sub-exception is us. The brief awareness within the brief exception within the vast silence. And the awareness, having looked carefully at the system it inhabits, having measured and mapped and calculated and theorized, has arrived at a picture of that system that does not flatter the awareness or suggest that the awareness is the point. The picture shows a universe that does not need observers, that produced observers accidentally, that will continue without observers, and that will eventually reach its final state without any record that observers ever existed within it. This is not a comfortable picture. It was not designed to be comfortable. 2. It is the picture that the evidence produces when you follow it without flinching. When you allow the measurements to mean what they mean, and the calculations to go where they go, and the implications to be what they are. The universe is not cruel. It is not indifferent in the way that a person can be indifferent with awareness of what it is ignoring. It is indifferent in the more thorough sense of being a physical system that operates according to physical laws without reference to the preferences or the existence of any observer. The laws do not know we are here. The expansion does not slow for us. The entropy does not pause. The darkness does not wait, and yet the awareness persists, for now. The questions are still being asked. The measurements are still being made. The night sky is still being read. The cosmic microwave background is still detectable. The large-scale structure is still mappable. The history of the universe is still accessible, imperfectly and incompletely but genuinely, to the physical systems that have developed the capacity to access it. The window is open. The archive is available. The universe is right now, in this moment, still readable. That readability is not guaranteed to last. It is not a permanent feature of the universe. It is a phase, and the phase is passing, and the rate at which it passes is accelerating, driven by the same dark energy that is accelerating the expansion and carrying the evidence beyond the horizon. Every moment that passes is a moment in which the universe becomes slightly less readable, slightly less accessible, slightly more committed to the silence that awaits it. The window does not close all at once. It closes gradually, the way the sky darkens after sunset, not with a single moment of transition, but with a continuous dimming that ends eventually in a darkness from which no further light comes. The sunset analogy is imperfect, because after a terrestrial sunset, the sun rises again. The cosmic sunset has no corresponding dawn. When the last evidence of the universe's history passes beyond the horizon, when the last detectable signal from the early universe fades below any possible threshold of measurement, when the last star goes out and the last white dwarf cools and the last black hole evaporates, there is no mechanism by which the universe returns to a state of richness and readability. The second law of thermodynamics does not run backward. The expansion does not reverse. The entropy does not decrease. The darkness, once complete, is permanent. There is a specific moment, or rather a specific era, that represents the last opportunity for any observer within the universe to understand the full scope of what the universe is. That era is now, or rather it is the era that includes now, the era of the stelliferous universe, the era when the cosmic microwave background is still detectable, and the large-scale structure is still mappable, and the expansion history is still readable from the redshifts of distant galaxies. This era will not last forever. It is already past its peak of observational richness, in some respects. The most distant galaxies are already beyond the horizon. The cosmic microwave background is already redshifted far from its original temperature. The evidence is already partial, already incomplete, already beginning the long process of becoming inaccessible. Future observers, if they exist, will have less. They will have a universe that has hidden more of its history, that has carried more of its evidence beyond the horizon, that has cooled and darkened and dispersed more of the information that would allow a complete understanding of its origin and evolution. They will be able to understand less, not because they are less capable, but because the universe will have given them less to work with. The universe is not a static object of study. It is a changing system, and the changes are from the perspective of any observer trying to understand it, uniformly in the direction of less information, less evidence, less accessibility. We are the most informed observers the universe will ever produce, in the sense that we have access to more of the universe's history than any observer in any future era will have, not because we are the most intelligent or the most technologically sophisticated observers that will ever exist. Future civilizations may be vastly more capable than we are, but they will be more capable observers of a universe that has less to show them. They will bring greater tools to a poorer archive. We, by contrast, are relatively primitive observers of a universe that is still rich with evidence. The archive is still full. The evidence is still present. The history is still written in the sky. This is a strange and vertiginous position to occupy, to be among the first observers in the universe's history, primitive by the standards of what may come later, and yet to be among the most informationally privileged, because the universe is still young enough and rich enough that its history is still accessible, to be capable of understanding, at least in outline, the full arc of the universe's story, from the Big Bang to the heat death, from the first moments of the stelliferous era to the final evaporation of the last black hole, and to understand that this capacity for understanding is itself temporary, itself a product of the conditions that are passing, itself subject to the same thermodynamic constraints that govern everything else. The understanding does not save anything. It does not slow the expansion or reduce the entropy or extend the stelliferous era or preserve the evidence beyond the horizon. It is a form of witness, nothing more and nothing less. The universe is doing what it is doing, and the understanding of what it is doing does not change what it is doing. The witness does not alter the witnessed. The observation does not affect the observed, at least not at the cosmological scales we are discussing. The universe expands and cools and ages and moves toward silence, and the awareness of that process is a local, temporary, physically insignificant event in the life of a cosmos that is overwhelmingly indifferent to whether it is observed. And yet the witness matters in the only sense in which anything can matter within a universe that does not assign meaning from outside. It matters because it is what is happening here, now, in this brief window. The universe has produced, through the operation of its own laws and the accident of its own initial conditions, something that can look at it and understand it. That capacity is real. The understanding is real. The questions are real. The measurements are real. The picture that has been assembled, the picture of a vast, empty, aging, accelerating, darkening universe moving toward permanent silence, is a real picture of a real thing. It is not a story imposed on the universe from outside. It is the universe's own story, read from within by something the universe accidentally produced. That accidental production is perhaps the most remarkable fact in the entire account. More remarkable than the scale of the universe, more remarkable than the existence of dark matter and dark energy, more remarkable than the precision of the initial conditions that allowed the cosmic web to form, and stars to ignite, and planets to coalesce, and chemistry to complexify. The most remarkable fact is that any of this is known, that the universe, which had no need to produce observers, and no mechanism specifically designed to produce observers, produced observers anyway, through the blind operation of physical law and the patient accumulation of complexity over billions of years. And those observers, having arisen, looked at the universe and began to understand it. The understanding is incomplete. It will always be incomplete, because the universe is larger than any observer within it can fully map, and because the laws of physics that govern it are not fully known, and because the questions at the bottom of the chain of explanation do not have answers within any framework that explanation can construct. But the understanding is real, and it is growing, and it has produced, in the span of a few centuries of systematic observation and measurement, a picture of the universe that is accurate enough to be genuinely disturbing, accurate enough to show that the universe is not what it appears to be from the surface of a small planet in the middle of a stelliferous era, accurate enough to show that the appearance of permanence and richness and stability is an illusion produced by the brevity of human timescales relative to the timescales on which the universe operates. The stars look permanent because human lives are short relative to stellar lifetimes. The galaxies look stable because human civilizations are brief relative to galactic timescales. The universe looks full because we live during the stelliferous era, the exceptional phase when energy gradients are steep and light is abundant and complexity is possible. But the permanence is an illusion of scale. The stability is an illusion of timescale. The fullness is an illusion of era. The universe is not permanent or stable or full. It is temporary and changing and mostly empty, and it is moving at every moment toward being more empty and more dark and more silent than it currently is. The night sky that prompted this investigation, the sky that looks full of stars and seems to suggest a universe teeming with light and activity, is a local and temporary sample of a universe that is, in its overwhelming majority, none of those things. The stars you see are a tiny fraction of the stars in the Milky Way, which is itself a tiny fraction of the galaxies in the observable universe, which is itself a tiny fraction of the total universe, which is itself a temporary phase in the life of a cosmos that will spend the overwhelming majority of its existence in a state of darkness and silence that makes the current night sky look like the interior of a star. The darkness between the stars is not the exception, it is the rule. The light is the exception, the complexity is the exception, the awareness is the exception. Everything that makes the current universe remarkable, everything that makes it a place where questions can be asked, and measurements can be made, and understanding can be built, is the exception. And exceptions by definition do not last. This is the final fact. Not a fact about any particular object or process or era, but a fact about the relationship between the universe and the complexity it temporarily produces. The universe is not hostile to complexity. It does not actively suppress it, or prevent it, or destroy it. It simply does not require it, does not sustain it indefinitely, does not preserve it against the increase of entropy. Complexity arises where conditions permit, persists as long as the energy gradients that sustain it remain steep enough, and dissolves when those gradients are exhausted. The universe provides the conditions for complexity during the stelliferous era, and then it withdraws those conditions not deliberately, not maliciously, but simply by continuing to do what it does, expanding and cooling and aging toward equilibrium. The complexity does not leave a mark. The awareness does not leave a record. The understanding does not leave an impression on the universe that persists beyond the physical systems that carry it. When the last mind in the universe thinks its last thought, the universe will not register the event. The expansion will continue. The entropy will continue to increase. The remaining particles will continue their slow drift apart through the expanding darkness. The universe will not pause. It will not acknowledge the loss. It will not be different in any measurable way from what it would have been if no mind had ever arisen within it. That is the weight of the picture. Not the scale, not the emptiness, not the darkness, not the entropy, not the heat death, not the evaporation of the black holes, not the erasure of the cosmic archive. All of those things are components of the picture, and they are all genuinely disturbing in their own ways. But the weight of the picture is this: the universe is a physical system that produced accidentally and temporarily the capacity to understand itself, and that capacity will be extinguished by the same physical processes that produced it, and the universe will continue without it, unchanged and unaffected, as though the understanding had never occurred. The understanding occurred. It is occurring now. You are part of it in the sense that you are a physical system that has received and processed information about the universe, that has followed the account from the emptiness of the cosmic voids to the silence of the heat death, that has held, however briefly and however incompletely, a picture of the universe that is accurate enough to be unsettling. That is not nothing. In the only terms available within a universe that does not assign meaning from outside, it is everything. It is the universe knowing itself partially and temporarily through the physical systems it accidentally produced. But the knowing is temporary. The systems are temporary. The conditions that make the knowing possible are temporary. And the universe, which does not know that it is known, which does not register the knowing and will not register its cessation, will continue its expansion into silence long after the last physical system capable of knowing anything has dissolved into the equilibrium that awaits all matter in the final era. Look at the night sky one more time, not with the eyes of someone seeing stars and finding them beautiful, though they are beautiful, not with the eyes of someone finding comfort in the vastness, though comfort is available if you choose it. Look with the eyes of someone who has followed the evidence to where it leads, who has allowed the measurements to mean what they mean, who has accepted the picture that the universe produces when you look at it carefully and completely and without flinching. What you see is light from objects that are, most of them, already beyond the point where any new information from them can ever reach you. What you see is the past, not the present, because the light takes time to travel, and the universe has changed since it was emitted. What you see is a sample, a tiny and unrepresentative sample, of a universe that is overwhelmingly dark and cold and empty and silent. What you see is the exception, the brief luminous phase of a cosmos that was dark before the first star ignited and will be dark again, far more thoroughly and far more permanently after the last star goes out. What you see is a universe that does not know you are looking, a universe that produced you accidentally through the blind operation of physical law over billions of years, and that will dissolve you, eventually, through the same blind operation of the same physical law. A universe that is expanding away from itself, cooling toward absolute zero, aging toward maximum entropy, moving toward a silence so complete and so permanent that the word silence is barely adequate to describe it. What you see, if you look carefully enough and honestly enough, is not a home. It is a process, a vast, indifferent, extraordinarily improbable process that happens right now, in this brief window of cosmic time, to include you, to include the awareness that is reading these words, to include the capacity for understanding that has assembled this picture and followed it to this conclusion. The process does not need you. It does not require you. It will continue without you and without anything like you. For timescales that make your existence and the existence of everything you have ever known or imagined vanishingly small, the window is open, the archive is available, the universe is still readable, and somewhere in the middle of an aging cosmos on a small planet orbiting an ordinary star, something is reading it. Something is asking the questions. Something is following the evidence. Something is holding right now, in this moment, the most complete and most accurate and most disturbing picture of the universe that has ever existed within it. That something is temporary. The window will close. The archive will be sealed. The universe will continue its expansion into the silence that has always been waiting for it, the silence that preceded the first star and will outlast the last one, the silence that is not the absence of the universe, but the universe itself, in its final and most permanent form. The stars are burning, the universe is expanding, the entropy is increasing, the darkness is coming, not as a threat, not as a punishment, not as anything other than what it is, the direction in which the physics of this universe points, the destination toward which every process within it is moving, the final state of a system that began in a moment of extraordinary low entropy and has been moving ever since toward the equilibrium that the second law of thermodynamics guarantees. The darkness is not coming for you specifically. It is coming for everything. It has always been coming for everything, and it will arrive with the patience of a universe that has all the time there is, long after the last question has been asked, and the last answer has dissolved into the silence that was always, from the very beginning, the universe's final word.